Chemistry, we're moving on to our second type of chemical bonding, and it's called covalent bonds. So covalent bonds occur when two or more atoms share electrons. Covalent bonds occur primarily between nonmetals such as carbon, nitrogen, oxygen, phosphorus, hydrogen, sulfur, and chlorine, and the others. Covalent bonds produce combinations of atoms called molecules. Covalent bonds are the bonds that are found in you and other living organisms. So covalent bonds share, just remember that. When nonmetals bond, they pull each other's electrons very hard because they both have high electronegativity. Since both have high ionization energies, they don't easily give up electrons. It's two strong guys having a tug of war. Nobody wins. Consequently, the two atoms share electrons. So just have that image stuck into your mind. Two strong guys having a tug of war, they have to share the electrons. So the octet rule says that atoms are most energetically stable when they can fill their valence orbital. Octet means 8. It's called octet because elements in the second period and below need 8 electrons to fill their valence orbital. So oxygen has 6 electrons in its valence orbital. Oxygen would like to fill the 2 empty spaces. Okay, but how? How does it do this? Okay, now hydrogen's valence orbital can hold 2 electrons. So hydrogen needs 1 electron to be happy and fill its valence orbital. And again, the question is how? So note that even though hydrogen's first orbital can only hold 2, not 8 electrons, it's still called the octet rule. The main idea is that an atom wants to fill its valence orbital. So here we'll see how water is formed. Each hydrogen shares its electron with oxygen. This gives oxygen a total of 8 valence electrons, so oxygen is happy. Oxygen shares an electron to fill the valence orbital of each hydrogen as well. So watch what happens. So that hydrogen moves in and shares its electron with the oxygen, and then the other hydrogen moves in and shares its electron. Also, the oxygen shares its electron with each of the hydrogens. Okay, so you see those 2 pairs of electrons are being shared. Okay, so because hydrogen atoms fill the valence orbital of oxygen and oxygen fills the valence orbital of the 2 hydrogens, this combination creates H2O, or water. These electrons are double counted. They both belong to the hydrogen atom, and at the same time, they both belong to the oxygen atom. They're effectively being double counted. And both hydrogen and oxygen are right. They do belong to the hydrogen, and they do both belong to the oxygen. Same with these 2 electrons. They're also being double counted. They both belong to the hydrogen atom, and at the same time, they both belong to the oxygen atom. Okay, so the bonds created between nonmetals by atoms sharing electrons according to the octet rule are covalent bonds. So notice that covalent bonds don't involve positive and negative charges. The reason they bond is because they can share electrons to fill the octets of each other. That means they're going to a lower, more stable energy level. So remember, covalent bonds share. Now, you should know the 7 elemental diatomic molecules. An elemental diatomic molecule is a bond between 2 atoms of the same element in gas form only. We're only dealing with gases. That is, separate molecules that move about independently, such as air, the oxygen and nitrogen in the air. Diatomic molecules are the most common covalent bonds in nature. There are 7 elemental diatomic molecules. 4 of these are halogens with 7 valence electrons. So they are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Notice over on the right they form the number 7, and there's 7 of them. So that's only 6, so the 7th one is over on the left, and that's hydrogen. So in gas form, for example, the oxygen we breathe is not oxygen atoms. It's oxygen molecules, O2 molecules. Okay? These elements always form diatomic molecules when they're in gas form. Polar covalent bonds happen when one of the nonmetals is slightly stronger than the other and pulls the electrons a little more towards it. So nitric oxide, NO, you can see that oxygen, if you look at your periodic table of electronegativities, is more electronegative than nitrogen. It's stronger than nitrogen. So if one of the atoms has a higher electronegativity, it will pull all of the electrons closer to it, creating a polar covalent bond. Oxygen is more electronegative, stronger than nitrogen, which is weaker, and pulls the electrons towards it, but does not totally take them away. That would be an ionic bond. So the atoms still share. The side of the molecule with the more electronegative atom in a polar covalent bond has a more negative charge. The side with the less electronegative atom has a more positive charge. So oxygen is more electronegative than hydrogen, so it pulls the electrons towards it. The water molecule below is polar. So if you look at the side in red, this side of the molecule contains the nuclei of the 2 hydrogens. You can see them up there in red. And therefore that side is more positive. The red rectangle has a charge of 2+. Now if you go down to the bottom, this side of the molecule contains 8 protons and 10 electrons if you count them all. The blue rectangle has a charge of 8 minus 10, or 2 minus charge. So it's more negative, the blue. The red is more positive. So a polar molecule is electrically neutral in this case. They're not always, but this one is. It's still electrically neutral. 10 protons, 10 electrons. However, it has a positive side, the delta plus, and a negative side, the delta minus. This means that it acts like a magnet when other polar molecules are nearby. Okay, so covalent bonds form molecules. These H2O water molecules, for example, are separate structures from all other water molecules. When water boils, the water molecules separate and move freely. So you'll notice some of the steam goes up in one direction, some of the steam goes in the other. So the analogy, unlike ionic bonds, which are like apartments in an apartment building, which you cannot separate from the apartment building, these are independent structures. So think of molecules as cars that can move independently like that. Okay? All right, so that takes care of this lesson on covalent bonds, and we'll be talking about these throughout the entire course.